We could build the fastest serverless platform in the world, but if we couldn't deliver that data to users very quickly, it didn't matter. And so we began looking for a partner in the ecosystem that would be able to provide what we were missing. Hi, I'm Matt Butcher, the CEO of Fermyon Technologies, where we're building the next wave of serverless functions with WebAssembly. We started the company because what we were hearing from developers around the world was that they really liked the idea of serverless functions. We could build the fastest serverless platform in the world, but if we couldn't deliver that data to users very quickly, it didn't matter. And so we began looking for a partner in the ecosystem that would be able to provide what we were missing, but that the platforms that were available to them, things like AWS Lambda, were slow and cumbersome to develop on and also didn't sort of meet their needs when it came to performance and availability. And oftentimes they found themselves spending more time setting up and managing the infrastructure around these projects than they did actually writing these very elegant small bits of code. Now at Fermyon we said, hey, that's a problem we want to solve. And we began looking for sort of a rudimentary technology that would enable us to build a highly elegant solution to that problem. What we discovered was that there's this technology called WebAssembly that was very fast, very secure, very efficient with resources. And we began building a new serverless environment on top of that. Now at Fermyon, we consider ourselves a bunch of compute nerds. We really like solving compute problems. But at some point, we realized that solving the performance and development half of the equation was not enough to meet the customer's need. We also needed to solve the network piece of the equation. The expertise we had, the product line we had, and Akamai is already the world's biggest distributed platform. As we began looking into the technology, we said, this is fantastic. This is exactly the kind of technology that pairs with us. We can deploy the world's fastest serverless environment on the world's biggest distributed network and solve both the compute half of the equation and the networking half of the equation. So I'm happy to join Ari here today, where we're going to talk about serverless functions, edge native computing, and all the exciting things going on with the future of edge.
I'm Ari Weil, VP of Product Marketing at Akamai Technologies. As we continue to evolve and work with our customers, something that we heard was, as Akamai provides edge computing solutions for websites, games, and media applications, could we add more stateful full-stack computing that would reach out to the edge of the internet? Because that's where decisions are made, because that's where the content exists, and that's where users are really engaging and expecting the sort of experience that will make them loyal advocates of a brand. And when we thought about what would really make developers successful, we realized that making it easier to develop an application and then seamless to distribute it on Akamai's global infrastructure would really unlock value for a new class of developer that was developing edge-native applications. Edge-native applications rethink the paradigm of centralized cloud computing by distributing compute resources out to the edge. It provides you with the option of having stateful, heavy computing at the core, extending to more lightweight use cases in a distributed tier, and ultimately reaching the edge of the internet with serverless experiences. As Matt was saying, partnering with Fermyon to add the world's fastest WASM platform on top of Akamai's distributed infrastructure really looks to unlock value for developers as they invest in the next generation of applications and start to add AI to power more exciting, more interactive experiences across industries. And so I'm really excited to be joined by Matt today and look forward to the conversation. So with no further ado, Matt, for those newer to WebAssembly outside of the browser, how do you explain its role in cloud computing?
One of the most enticing things about working in technology is seeing a technology that was built for one reason find a home in a completely different environment, right? If you think about how Java got started, it was designed for small devices, and yet it powers many of the world's biggest enterprises now. If you think about the World Wide Web, it was designed for trading physics papers, and now of course we know that the potential is much, much greater than that. WebAssembly was originally built to run inside of a web browser, and the problem that it was to solve was to allow software developers to use languages other than JavaScript and run pieces of code inside the web browser. This would allow a lot of code reuse. It would allow emerging languages like Rust to find a home in the browser, in addition to being able to use older languages like C. And the browser companies that invented this all worked together. It was one of the most collaborative, Microsoft IE team, the Chrome team at Google and the Safari team at Apple all joined in with Mozilla, who offered this idea originally, and said, yeah, let's work together, let's build a standards technology. Now, those 4 companies are very interested in security. When you think about our web browsers, it's probably the most trusted piece of software we have. We don't even give a thought when we visit a website over who created that website and what they used and whether they might have any, malicious intent. We just rely on our web browser to keep us safe. So that means one of the things that browser technologists are very interested in is security. Now, the other thing that Akamai knows better than probably any company on the planet is that end users are very impatient. We want to see content delivered in the blink of an eye, right? 100 milliseconds ideally. And so the web browser vendors who were building WebAssembly said, okay, so it's got to be very fast. So secure and very fast. And of course, WebAssembly has enjoyed tremendous success in browser technology, in the browser through a number of different applications. But what we saw there was an engine that would actually be ideal in the cloud. Now, what we had heard from software developers and engineers is that they like this serverless paradigm that we talked about in the introduction, right? This idea that you write a small piece of code that takes a request, does a little bit of processing, returns a response, and shuts down. Now, in order to effectively be able to start up and shut down like that, you need something that runs in the blink of an eye. You need a highly efficient compute engine. Now, first wave compute technologies like virtual machines and containers are not designed to start up and shut down very quickly. So we needed a new technology. Originally, we were going to build our own. But then when we saw WebAssembly, we thought, oh, this is a fantastic technology. It has the security profile that you need for a cloud environment. And it has the runtime characteristics we needed for this kind of serverless functions. So we took that runtime and put it in the cloud on the server side and could achieve nearly instant startup times. And so because of that, we are just tremendously excited about the potential that serverless computing has now that we've got a cloud-side runtime powered by WebAssembly that can meet that kind of demand that the user has on the performance side and that we as good cloud vendors have on the security side.
That sounds exciting. So let me ask, it's always interesting to develop technology that's based on some standards because it means that you can address more developers, and it also means that they have the feeling that it's worth investing, worth learning your technology because it allows them to really pick their platform of choice and deploy things across more clouds, more networks, a diverse set of architectures. So curious about the pain points that Fermyon specifically is solving for WebAssembly, and maybe a little bit about some of the early applications that you're finding success with.
The serverless computing thing really took off when Amazon introduced Lambda. So Lambda was sort of the original serverless functions platform, and it was designed to make use of spare computing cycles within AWS in order to provide a small amount of value to developers. But what has happened over time is that developers like that model, like that serverless function model, and so they continued to invest. They continued to build more and more. In fact, Amazon says they have trillions and trillions of invocations of Lambda per month. And developers have told us repeatedly that they like that particular paradigm for building applications. But there are a couple of problems in the kind of first generation of serverless technology. The first one is developer experience has been very hard because you can build something and you can deploy it, but you end up having to manage a whole lot of infrastructure. And in particular, if you're deploying only to one data center, you don't have sort of the global coverage that developers desire for today's applications. The second piece is developer experience, right? Developers want the fastest possible way to get from a blinking cursor to a deployed application. They don't want to have to jump through a lot of hoops. They don't want to have to learn a whole lot of new technologies. They want to be able to focus on the problem at hand and solve it and get it out there. And then, of course, there's the performance problem, right? You want to be able to do this in such a way that the user is getting that interaction within the blink of an eye, within 100 milliseconds. So with these problems then, it gave us a very clear idea of what serverless functions v2 would have to look like, right? What the next generation of serverless computing would have to look like. Really good developer experience, minimal investment in your infrastructure, and of course, very good performance. When we built Fermyon WASM functions, we really started with the developer experience problem. And we said, as our core user story, the entire first year Fermyon existed as a company, we said, Our priority is that for a developer, they should be able to get from that blinking cursor, that empty project, to a deployed application in 2 minutes or less.
Wow.
We focused on building developer tools that worked well with their existing workflow, that made it easy to test locally, that made it easy to run locally. And then we built a tooling that would allow it to be deployed out into Akamai's network instantly. You deploy it once, it deploys out globally. They're not managing infrastructure, so that takes on that second problem, right? They're not managing infrastructure. They're not thinking about, is it running here, is it running here, is it running here? It's just running globally. And then that third part is the most exciting part to me. When we looked at the performance of AWS Lambda, the original serverless platform, what we saw was cold start times that were going from 200 to 400 milliseconds. Now what that means is that from the time the request enters the system, there's a 200 to 400 millisecond delay while the system is setting up before the software developer's code even begins to execute. Again, we cannot meet the demand of our end users that we're delivering in the blink of an eye if we got 200 to 400 milliseconds, nearly a half a second of just stalled out time before the code is even beginning to execute. That's where WebAssembly really shone as a core technology for us. And we were able to get that cold start time from 200 and 400 millisecond range down to 1/2 of 1 millisecond,
Wow.
the blink of an eye.
So sticking with the blazing fast speeds theme, GPUs are something that are in extremely high demand. We've heard a lot about them for video transcoding use cases, gaming use cases, and then certainly as people become enamored with and try to chase the power and potential of AI, people are snapping up GPU resources everywhere. If we think about looking at GPU time slicing, which is something that Fermyon's been looking into, and it sounds like a win on the speed front, it sounds like a win on the efficiency front. Explain how that helps customers get access or developers get access to GPU resources in a way that otherwise maybe they couldn't.
When you're building a compute company and a technology like AI comes along, people might think, oh, well, this is a different problem space altogether. Well, no, it's not a particularly different problem space. GPU is another form of compute. So as we looked at the problems that we were seeing in that sort of very first year of AI enthusiasm, we were seeing people frustrated with the fact that they were paying a lot of money for very, very expensive GPUs, which could do double duty as either training GPUs, where you can train your own language models, or as inferencing GPUs, where you use that model. And we saw a lot of frustration that the availability of the GPUs wasn't there. They were writing a lot of code just to try and squeeze the efficiency out of these very big investments. And we said, okay, this is a compute problem. We're compute problem people. Can we take the same kind of model we were using with WebAssembly on the CPU and introduce efficiency on the GPU side of things? Now, our first gamble there, which I think has turned out to pay off really well, was that inferencing is the technology that was going to need to scale the best, right? We're going to train models only rarely, but we're going to use models, inference against models, all the time. And the more successful AI is, the more we're going to be doing this inferencing, right? And so we began to investigate a technology that would take those big GPUs and be able to effectively time slice them so that we could launch a serverless function, claim a tiny bit of GPU space, do the processing, shut it down, free up that GPU space again. And we could effectively have many, many tenants running their inferences against the same GPU without any security implications and without any risk. That was the first wave of our Fermyon serverless AI platform. Now, as we've started working more with Akamai, and Akamai has introduced GPUs into the Akamai Cloud, we've discovered that our first model was a little bit limited, and that in fact, there was a better way even to do this. So if Akamai's Cloud introduces GPUs all around the globe, and Fermyon functions are running all around the globe on the Akamai network, then suddenly we could say, okay, we don't need to have one central GPU that we effectively time slice. We can say, we got GPUs all over the place. When a function comes in Singapore, let's handle it on a GPU right there. When a function comes in Dallas, Texas, let's handle it right there. And suddenly the whole process of optimizing for this kind of AI inferencing took on this more distributed characteristic, right? And we've found tremendous success because one of the things that we learned as we built this model is that we don't any longer need very large, very expensive GPUs, the ones that are still scarce today, because we're not time slicing several thousand functions over one particular GPU. Now we're processing them globally on smaller GPUs that are all sized just perfectly for inferencing. So again, this is one of those cases where Akamai's ability to deploy hardware out to many, many locations around the globe has resulted in a very real computational gain for people who are using Fermyon WASM functions.
That's exciting. So if I think about then a natural extension to what you were just saying, you've said before, WASM is where containers want to be. And we always say that the edge is where your data and decisions need to be made, and it's really where your application needs to be. How do you think a little bit about, from a Fermyon perspective, why is WASM someplace where a container wants to be from your perspective?
Cloud was really a very centralized enterprise as it got started. Originally, you would stand up a virtual machine and you would manage that virtual machine in a data center somewhere. Along come, the so-called distributed platforms like Kubernetes, but you were really only distributing within your data center and saying these containers are going to run in 9 different places, all in the same data center, on adjacent virtual machines. And so we gave a lot of lip service toward getting toward a distributed computing platform. But in reality, we were still very centralized. Now, because Fermyon WASM functions can run inside the Akamai Cloud and distributed all around, it changes the tenor of that kind of conversation. Instead of talking about distributed as distributed across different compute instances in the cloud, we start talking about distributed as distributed across different compute instances all around the world. And if you can have sort of one central control plane that can manage those, which is what Fermyon WASM functions is in essence, move its way out closer and closer to the end user or closer and closer to the resources you care about. And you don't have to redesign your application for this. You don't have to upskill all of your developers into a more sophisticated distributed application platform. You just have them write these small and concise WASM functions, right? Again, taking on the virtues that drew developers toward Lambda originally, but now making it possible to do this in a much more distributed environment. So when I talk about containers as sort of like wanting to be in that, this is what, as we were building technologies like Kubernetes, and I was one of the people involved in that technology, one of the things we wanted to do was make it easier for people to build distributed applications. But we didn't get far enough with containers as they were 5, 10 years ago. With WebAssembly and on top of Akamai Cloud, now we've made that next big step toward running what we would consider edge native applications. So I've been using Akamai for a long time. I've been a long time fan since the 90s when I really got started as a developer. And Akamai over and over again has not just created a technology in an ecosystem. You seem to have created technologies that really define ecosystems. First, with CDNs, then again with security software. I'd love to hear from you. How do you see Akamai to this point, and where do you see it going in the next 5 to 10 years?
So Akamai has really worked to express to our customers the importance of networking, the importance of integrated technology and constant connectivity, really across any vertical, any industry. So when Akamai first started, we had our roots in media. And it was important to help to deliver streaming video use cases across the internet, because that was a challenge with the state of the internet, the amount of capacity that existed across different networks. And so for Akamai to create the world's most distributed global network was sort of the first stage in enabling what would be the future of application architectures that were really designed for distribution and for scale anywhere. So we were overcoming the bottlenecks of centralization. As we started to think about edge computing use cases, then the next question was, what are some of the things that we would do that would react more to how the end user was consuming? So it would be what type of a device, or what sort of a screen were you looking at your content on? Or if you were interacting with a web application, were you on a desktop, were you on a tablet, were you on a mobile device? What was the speed of your network? How were you able basically to get the most out of that application? And how could a developer start to put some hooks into the application to define how it should actually perform based on the way that you were interacting with it, where you were in that moment? And so we were trying to add some determinism to what developers could expect would occur in an environment that frankly was more or less out of their control. And then as we started to really understand from operational teams, from DevOps teams, what are some of the additional challenges that you're facing as you try to scale your applications and build in more personalization or more dynamic content? We heard things like, well, there's operational complexity, and so we added a whole set of cloudlets to our network that would allow you to do things like image and video optimization and redirects. They were all small bits of code that facilitated scaling or adding richer experiences to applications that used to be centralized, but where we could affect really the performance and that personalization at the edge, just as you were saying, without materially changing the application itself. The ability for us to inject things into an application just in time to enrich the experience was sort of the beginning of opening up the platform to more development capability. So if we think about where that expanded and where we're heading at the moment, many of our customers and the developers working for our customers have said, you've got this globally distributed edge network, and we've got all of these POPs where we should be able to move more than just content. You've done it with some serverless functions, but they're small and they're stateless. What if I needed to add a more robust or a more stateful application to that environment? So we've started to evolve it so that we can host VMs and containers on the edge and take a lot of the operational complexity out of scaling your compute. Because if you think about the core model dovetailing to the edge, developers will build their applications and they'll deploy them centrally on a hyperscaler. And they have a choice, typically around major metropolitan areas, for where they can host that application code. They'll create redundancy with high availability and disaster recovery built in, but that's just to make the app available. If you're trying to reach a user in a new market, maybe it's a market that's underserved by the hyperscaler, maybe it's a market where you don't have necessarily enough of a business case yet to justify deploying additional code or additional infrastructure with that hyperscaler, Akamai can now help you start to carry the code out to the edge where we have presence already, but help you with that scale, help you to reach that user base in a more consistent fashion that is operationally simpler, because we can start to take code and ship it from the core to the edge seamlessly on one platform. It also frees you from some of the constraints that you have about moving your data from a hyperscaler platform onto an edge delivery platform. We don't have to pay the egress fees if we host the application code on Akamai. If we distribute it out to the edge, we don't have as many points of failure that we have to troubleshoot. And if you're composing an application from a hybrid set of cloud resources, maybe you've got on-prem or otherwise hosted or colo space that you're paying for in addition to private and public cloud infrastructure, Akamai can start to combine those things and provide more of a seamless transition to the user by putting full stack computing and carrying that out to the edge all on our network. And that's why we're so excited about the fact that we've been building the Akamai Cloud onto Akamai's high performance network, because the application itself now has better performance from data center to data center and from data center to edge in a way that you just can't realize on the legacy hyperscaler platforms.
So I'm hearing you talk a lot about how Akamai has gone from being a distribution company and providing distribution at edge to really toward providing compute at edge. Can you tell us more about Akamai's strategy for edge computing, for edge in general, and how Akamai is shaping it with innovative solutions, other partners like Fermyon and other vendors, and what the journey has been like so far?
So one of the most exciting things about the Akamai Cloud is that we have built it with the developer in mind. The first thing that we said was, what's the easiest way to ensure that as many developers as possible can develop and code on our platform? The answer was open source. And so everything about Akamai Cloud is based on Linux. If you know Linux, you can code on Akamai. If you understand Kubernetes, you can use platform operations and really scale using containers on Akamai. So that was the first thing, is let's make sure that as many developers can code on the platform as easily as possible. The next thing that we thought was, if you want to have the flexibility to define where compute should happen, let's ensure that we have core distributed and edge locations with a very clear way for developers to understand what sort of compute tasks they can run at each stage, and make it very easy for them to access and manage their compute in all of those different regions. But we didn't want them to really obsess over, where do I need to think about scaling my application? When do I have to scale it? All of the operational complexity that for years we'd been abstracting away with the CDN, we wanted to continue abstracting away for developers as they were building their next generation of applications. And that's where we started to consider our managed container service as a way to really streamline application development and deployment, because by so doing, you can create a containerized version of your application. You can tell Akamai, this is the set of business logic that should govern how you manage and operate the infrastructure for my application for me. And then Akamai can distribute your application code in a containerized environment across our edge network. If we do that, you operate your application. You can see all of the metrics that define how you're scaling, how it's performing, any tuning or optimizations that you need to make. We, in the meantime, can make sure that we understand, based on demand, where do we need to scale out and then scale up those containers so that we're providing that continuous and seamless experience to your users. We're maintaining that low millisecond performance that you are articulating that's so important to developers as they code up WASM functions. And then for us, we would ensure the inherent security and stability of the edge was part and parcel of distributing that application. But really, we're providing you with the easiest way to bridge between the centralized model and what we're now evolving into with edge native applications without having to re-platform or consider new architectures that are unfamiliar while you're charting new territory with the application itself. For a developer or for a company that we contract with at Akamai, the goal for you is to scale your business and to make your business successful. It's not to figure out how to do that with the infrastructure that it's running on. And so we take our responsibility really seriously in that equation. But then when we think about what are one of the other considerations that a business has, it's flexibility. You need the flexibility to decide what is the right technology and the right partner for you. And so we've wanted to scale the Akamai Cloud with a robust set of ISV partnerships, companies like Fermyon that can provide the developers that we work with the best choice to develop their applications, whether that's distributing data, whether that's distributing functions, the way we would think about transcoding or packaging or optimizing media resources, and the list goes on and on. So we have wanted to supplement what we do with a really robust set of service partners, but have those partners build onto our network as well, so that they can realize automatically the stability and the scale of Akamai, but still the richness and the differentiation that make all of our partners stand out and successful in their own right, so that together we're creating the most appealing environment for developers that we can, that guarantees performance, it guarantees scale with the security tools built in, so that for them, the real goal is how do I ensure the best development and application experience, not how do I choose the right infrastructure and then modify that infrastructure as I grow. You focus on growing your app, we'll focus on delivering your application.
And in fact, at Fermyon, that is one of the things we have appreciated the most about working with Akamai. I set out with this vision, we wanted to build the fastest serverless functions platform. But what we've discovered is because Akamai brings this robust ecosystem that includes everything from CDN and edge workers and the whole Akamai Cloud infrastructure suite, all of which we use, it also includes a number of other partners in this ecosystem that we've also been able to collaborate with to accomplish things that, frankly, Fermyon could not have done if we had gone it alone. So I think you defined edge native applications as sort of breaking out of that mold where you think in terms of a data center that's running your big application and all these little edge assistive functions, and started to challenge that idea and say, what if we just run our applications on the edge in this more distributed environment, taking advantage of all these services that Akamai already has. Where do you see sort of the most potential for these edge native serverless functions to disrupt the way people are thinking about things and the kinds of applications people are building today?
So I think to some extent what's old is new again. And that really is something where we talk to our customers, gives them a lot of confidence to start experimenting with what they might consider a next generation experience. For example, if we think about media delivery, once upon a time, it was the most advanced thing that we could do with the media stream was to chop it up into small pieces, distribute it around the edge, and then make sure that as users were consuming that stream, we could assemble it just in time so that they would have a seamless experience, no buffering, no errors, the best possible picture quality. And that was sort of the best that we could do and really the best that a user would expect from us. Nowadays, if you think about how social media has changed the way that we engage with content, if you think about how mobile devices and sort of the mobile era meant that we were constantly connected but also expected to have a consistent experience when I started watching something on a television, maybe I continued watching it on a phone if I had to move somewhere, and then maybe I decided I was going to sit on a couch and continue watching it on a tablet. What my expectation would be is that it would feel and look the same, even if the viewport was different, the power of the application was different, and maybe the way that I was interacting with it was slightly different. But now, I've added more expectations on top of it. I don't just want to watch something from a streaming service. I might want to interact with that stream. I might want to choose what happens next in my favorite show. Or I may want to have a watch party with a bunch of my friends and start maybe talking about what's going to happen next, or what did you think of that last scene. Some people are really curious to understand who the actors are in a given scene. And so we're adding all of this rich data, and we're adding these small compute experiences throughout streaming experiences. And so now it's not just content delivery and optimization, it's optimizing a media-centric application at the edge. If I think about retail and commerce, we've for years tried to achieve personalization because customers want to be presented with something that means something to them. You understand my buying history, you are presenting me with the sort of goods that I might want to buy to continue engaging with your brand, not to show up and all of a sudden have you interact with me like I've never been to your site before. We used to use things like cookies to save little bits of information on a local machine, and sure, we still do that. But now the expectation is if I have an account with you and you have my purchase history and you know where I live and maybe I've told you what my social media handle is and whatever else I might share with you as a brand as I become a loyal member, my expectation in that transaction, in that relationship, is that you are going to use that to improve my experience. Well, that doesn't mean that you put me in with a cohort of users. I'm not like any other 40-something white male with no hair. I am somebody who has a very specific interaction with your company. You know what I like, present me with more of that. That requires me to do more compute in real time because I'm not going to code a deterministic path through my application for Ari Weil from Akamai. But I will do it for the user whose data I have access to so I can use that context, the context of how they're also engaging with my application in that moment, and maybe the context of what my marketing promotions are, or what goods I really need to push to make my business successful, but I have to assemble all of that and, to your point, deliver it to them in 100 milliseconds or less so that the user continues to engage with me. So personalization is actually becoming personal. And if I extend that to others, manufacturing has opportunities to really streamline and optimize the supply chain. With healthcare, we can come up with better outcomes for patients because we can assemble more of that, mission-critical, health-critical data in real time. That's the direction that we're seeing people take. But the way that we're seeing people productize and move some of their early investments in AI into production is to augment what we've already been doing so that we can have better efficiency, better repeatability, and ultimately better ROI from those processes, and also impact customer experience and customer lifetime value in a positive way. Where we're seeing people be a little bit more experimental and taking more time, but really seeing the potential of where edge native applications will provide them with further improving their customer experiences and outcomes are things like computer vision. So if you're providing me with access to an image of yourself so I can do a fit room test, how accurately can I actually recommend a wardrobe that's sized correctly that I can send to you once and delight you with? If I'm an insurance company, do a better job of processing claims when you upload information about damage to your vehicle and where you were when it happened and what the road conditions were. Taking a claims process from months down to potentially hours or days and providing the user with that reason to stay with the insurance company and to really double down on maybe adding more products to your portfolio. If I'm a financial services organization, I might think about how I would recommend to you the right card for you as a consumer or the right investment profile so that moving forward, you really understand the value that I'm delivering for you. But also as business models get disrupted, you've got banks that are sort of competing with fintech companies. Everybody wants to improve the customer experience, and really everybody can. But if you're adding compute and you're distributing the compute out to the edge, you're able to take that context of the user and the unique context and relationship that they have with you and put those together in ways that, again, maybe we've been doing with very basic cohort-based code. Maybe we've been doing it with a lot of user-assisted processes. But with edge-native applications and the addition of generative AI and AI inference capabilities, we can really have more automated, more continuous, and more consistent processes applied to our users to make our employees more effective and to help our businesses grow even when we're maybe not behind the scenes operating the application. And if we build WASM functions into this and really start distributing these bits of code that we can assemble more effectively, then I think what we'll see is a lot more of an organic development of a personalized and kind of custom tailored application experience across every vertical. That's where we feel like the power of the edge and the power of Akamai's network is going to unlock value for businesses across every vertical, and we're just getting started. The greatest thing is the way that we're getting started feels like we have the customer in mind from the very beginning. So Matt, having said that, if there was one thing that you could advise developers on for really taking advantage of developing and distributing their applications to the edge, what would it be?
I love the way that you articulated for different verticals, these different sort of visions for how things could go in the future. And it's not the far distant future. It's 6 months, 8 months, a year down from now. And in particular, with the potential that AI opens and all the existing Akamai tool set, we can begin building these edge native applications. So how do we go about designing these edge native applications? I think that's where I would zoom in and say the focal point here is that we need to evolve the way that we do our design process. So if we rewind about 10 years, the way we were building applications for the internet was as monoliths. We built one large code base that ran the entire site, the entire service. About 10 years ago, the microservice architecture began to disrupt that pattern. And the suggestion there was, hey, break your code into constituent parts. Have each microservice do just one thing and be really good at that, and that makes development easier, makes long-term code maintenance easier, and it makes the beginning of distributed computing easier. Again, when we're talking about distributed computing in the data center context. Well, now we've got a serverless technology, we've got all of these services that Akamai already provides, and we've got this problem space that you just articulated that is how do we get right as close to the user as possible? And that doesn't mean merely network delivery distance. It means how do we get to the data that the user has given us, and how do we react to that data? How do we personalize things? How do we be respectful of their privacy? And that's where we start saying, okay, the design process now has to begin with what components do we need for whom, or where do we need these components? Is it GPU intensive? If so, we're going to want it as close to the GPU as possible to do that inferencing faster. Is it sensitive to the user's privacy? In that case, we might want to get it as close to the user and make sure that that data doesn't even traverse the network all the way up. And so that's where I think I would end, with saying that as we design for this emerging edge native ecosystem, as we design using these new paradigms, the first question we ask is, what constituent parts go here, close to the user? What constituent parts go here, close to the GPUs? And what other considerations do we need to have in mind as we architect edge native applications?
Matt, this has been a great conversation. I really want to thank you for joining us.
Yeah, thanks so much for having me. It's been a pleasure.